Hello, biostatisticians. This is a brief video to walk you through the putting it all together of multiple regression. There are a couple of things that I want you to keep in mind in this video. First of all, I'm going to be relying on the example that I posted in Blackboard. So if you haven't looked at the example that I posted in Blackboard and watched the video that covers regression in that example and breaks the example down, it would be helpful to do that before you watch this video. It will also be helpful to watch the video on creating dummy variables before you watch this video. So if you haven't watched those yet, please go back and do so. Now in your example, or in your analysis number 3, you're asked to look at the relationship between change in BMI and the number of sessions attended. Does attending more sessions result in better outcomes? In the example that I provided in Blackboard, we're looking at the relationship between BMI pre-intervention and patient's education level. So we're regressing BMI pre on education. Remember, we always regress the outcome, y, on the predictor, x. So I'm going to follow that example, but in this case, I'm also going to add some controls. We're going to control for female, and we're also going to control for patient urbanicity. Now, female is already a dichotomous variable. It only has zeros and ones. So that means that it's basically already a dummy variable. Urbanicity, on the other hand, has multiple categories, which we can take a look at by going to Analyze Descriptive Statistics, Frequencies. And let's take a look at the frequencies of urbanicity. So I'm going to run frequencies for patient urbanicity. And here we have our frequencies. So we have 18 patients living in an urban area, 8 in suburban, and 4 in town or rural. Now remember that in regression, it's better to use the dummy variable format than it is to use a categorical variable. So what we're going to do first is we're going to create the dummy variables for urbanicity. So I'm going to go here to transform, and I'm going to go to create dummy variables. I'm going to make sure that here I have picked the correct dummy variable. So I'm going to go down and find patient urbanicity and move that over. So we're now creating variables for patient urbanicity or urban. All of these are going to remain the same in this particular example. We're going to use the value labels. We're going to be in ascending order. We're not going to worry about creating dummies for scale variables because this is not one. And we're going to create the main effect dummy. So the root names here are going to be urban as the root, just urban. What that's going to do is it's going to actually create dummies that are urban 1, urban 2, and urban 3. Once I press OK, it's going to come up and give us the report out. So we've created now 3 variables. Urban 1 is just urban, urban 2 is suburban, and urban 3 is town and rural. If we go back over to our variable view, we see that we now have these variables for urban 1, urban 2, and urban 3. So urban, suburban, and town and rural. We can investigate this a little bit more by looking at the frequencies again for these new urbanicity variables. So we're going to get rid of the one we had over there, and I'm going to pick all 3 of the urbanicity variables and take a look at those frequency tables. Now, if you notice, back up here when we first ran urbanicity, the urban category had 18 participants. If we go down here and look now, when urban equals urban, the value of 1 is for 18 participants. So all 18 people who are in the urban area have a value of 1. The other people have 0. If we go back up and we look at suburban, there were 8 people in suburban. Now we go down and we look at the dummy variable suburban, and we see that there are 8 people who have a suburban of 1 and 22 who have a suburban of 0. So these 3 variables reflect only those participants with a value of 1. The others have a value of 0. Only the participants that match that particular criteria. So we've created our dummy variables, and now we're going to go through and we're going to build some regression models. So we're going to start with the most basic regression model. We want to regress education on BMI pre. So we're going to go up here to regression, and we're going to go to linear. Our dependent variable, our outcome, is going to be BMI pre-intervention. Our first independent variable that we're interested in is going to be education level. So we're regressing BMI pre on education level. Okay, and now I'm going to press OK. So here's our regression output. My video goes over the regression output. Notice that we have a very small R squared, so there is not a strong relationship between education level and BMI pre-intervention. And we can go down here and take a look, and we also see that we have a non-significant relationship. So a very small slope, non-significant relationship here, and of course a t-value that reflects that non-significant relationship. So now we might be interested, if we start adding controls, how is that going to change? So we would again go back to Analyze, Regression, and Linear. And now we have patient education level here, and we might want to add patient gender. Okay, so now we've got two variables in the block, and we're going to press OK. Regression is run again, and now this time you see our R-square has gone up a little bit. Okay, the R-square has increased, and you see that the coefficients here have changed, although we still have no significance, but we now have two coefficients. We have one for education level and one for female. Still no significance. Now perhaps we want to look and see whether or not patient urbanicity makes a difference. So we're going to go back to regression and to linear. And now we're going to look at our urban categories here. I'm going to pick two. Now remember that town and rural was the smallest category, so I'm going to leave that one out. You can pick which category you leave out, but remember you need to leave one of those categories out. So I'm going to move over urban, and I'm going to move over suburban. So now we have 4 variables in this block, and I'm going to press OK. Okay, so now we have a regression that shows all 4 of those variables, and our omitted variable is town, right? And you see that we actually have an almost significant relationship, 0.08, or we could say significant at the 10% level, on urbanicity. And we also have an almost significant on suburban at 0.07. Both of those are significant at the 10% level. So we're looking at this and we're thinking, well, so maybe there is something worth investigating further in other analysis about patient urbanicity and the impact on BMI. Maybe now we are interested in adding age. So we would go back to Analyze, go to Regression, and go to Linear, and now just add patient age to that block of variables. So now we have an additional variable there. We would press OK and go in and take a look at it. Now notice what happens when we add in patient age. We are less significant, so we have a lower significant value here on urban, a lower significant value on suburban. And we see that nothing here is significant. But we do see that our R-square has gone up a lot. By adding predictors, we're able to understand more about the variation in our outcome variable based on the predictors that we're including in the model. But what we see here is that there is not a lot that these things that we're looking at have to do with participant BMI. Okay, only about 15% of the variation in BMI is explained by all of these predictors together, which means that it's not particularly predictive. There are still 85% of the variation that could be attributed to something else, like diet, like exercise habits, like predisposition to obesity. Could be any number of things that influence the patient BMI. We also notice that our overall model, the F statistic, is non-significant as well. Okay, so what I want you to focus on as you're working through your analysis is what our significant relationships are and how you interpret those results. So if we were to look at this, we would say that education level has no significant relationship on BMI when controlling for female, urbanicity, suburban, and patient age. Okay, when we say controlling, that doesn't mean that we have control over the variable. What it means is that mathematically we are including that in our model so that we can rule out that that variable, that observable variable, has an impact on our outcome in relation to the predictor variable. We're basically taking the influence that that additional predictor that we're controlling for has out of the influence between the main predictor and the outcome. Okay. If you have questions, feel free to email me. Hopefully this was a little bit helpful in terms of thinking about how to build your regression models. Have a good week, and we will talk to you soon.